Can you get on this side, actually, if you don't mind? Better lighting. Tom.
So what we have here is a boiler from our Keen car. This one's good enough for about 140 horsepower and about an 8-gallon an hour burner. And so what you do is this is the top and that's the bottom. And the burner, which is an oil furnace gun, comes in at an angle here. We have a combustion chamber. This is the combustion chamber. That's upside down, but that sits in here. So the flame goes around in this stainless steel thing and it burns and everything. And then the flame goes down and there's an opening in the bottom that the exhaust goes out. And your flame starts out at 3,000 degrees. And when it goes out, it's going out at, I don't know, 400 or 500 degrees.
Mm-hmm.
And this is where your steam comes out. These top two coils are the superheater. And that's where the steam gets heated the most, to 800 degrees. So what you do is you pump the water in the bottom, and the bottom has smaller diameter coils, piping. So the water starts out cold and comes up. The hot gases start out hot and go down, so that's your counterflow. Because what you're trying to do is to extract all the heat that you can out of the combustion gases. And the only way to do that is to have the cold water at the very last, that's the very last thing the gases touch. That's why we call that counterflow. And as a general rule, you always have your flame at the top going down and you have your water pump from the bottom up. Now you can do it differently, but it's fairly complex. And the white boiler from the white steam car had the flame at the bottom and the water going in the top. If you take a boiler that's shaped like this and you pump the water in the top, it'll all just flow all the way to the bottom. And so the white boiler had a whole series of loops that kept it from doing that. But it's a lot easier to just pump the water from the top up, have the heat going from the bottom.
From the bottom up.
Bottom up, the heat comes from the top down.
Simply because at the top it's going to be turning to vapor.
Well, simply because water's heavier and it's nice to use gravity when you're making these things. It's a lot simpler to have gravity on your side instead of be fighting it.
Yeah.
So that's it. So that's why you design them the way you design them.
So you don't have the heat from the bottom. So, I mean, this inexperienced way to think about it would be, okay, the flame is at the bottom and then you put in cold water at the bottom. But that's...
Well, you can do that, but you have to then, you can do that for some of it. But then you have to duct it because you can then put in what's called an economizer. You don't put in the cold water at the bottom, put the cold water and the economizer over here, but then you have to duct the flame up here and it goes over here. You have to be careful that your water doesn't just naturally flow to the bottom. You don't want the cold water down at the bottom where the flame is, because then you are very, very inefficient, because you're going to have 1,000 degree, your exhaust is going to be 1,000 degrees going up the chimney and you're going to lose a lot of that heat, so you're not going to have a very efficient system.
Yeah.
The question is, how do you get all the heat out of that hot gas? And so there's any number of ways of doing it.
So you want to get the hottest flame at the hottest water.
That's correct. Counterflow.
Counterflow. Okay.
Now, some people, for example, this Volkswagen has a boiler that's like this, but it's laying on its side. And they seem to be comfortable with that. The flame goes this way and the water goes this way.
So like the side, that boiler?
Yeah, and they say that that's actually kind of a good idea, because then you always have a little water left in the bottom of every tube, and when
Uh-huh.
it heats up, it starts to spin around. But, some people think that's a good idea and some don't.
Mm-hmm.
But who's to know? Who's to know what's going on inside one of those things?
Okay, so you just suggest a vertical standing boiler.
That's what
Heat
everybody else
exchanger.
does.
Mm-hmm.
Then it's real simple. Gravity helps the water.
Yeah, okay,
So that's the reason you design them the way you're doing.
okay.
Okay, good. Glad we had this little chat.